Ethernet protocols of physical layer. What is Ethernet? Most widely used local area network. When Ethernet earlier it started, right? It was offering bandwidth up to 2.4 Mbps. Small b bro. 2.4 megabits per second. Megabits, not bytes, bits. 2.4 Mbps. Then it came to 10 Mbps. Then it came to 100 Mbps. Okay. Then again it came to 1 Gbps. Then it came to 100 Gbps. This way, now it's something 1 Tbps, I don't know, maybe. Yeah. This is the evolution of Ethernet, okay. Something like, they call this fast Ethernet. They call this as fast Ethernet, okay. Fast Ethernet. This they call Gigabit Ethernet. Names are not important, bro. They will never ask. How Ethernet works. So, I explained you during OSI model. From network layer, packet comes. It will take frame, it will add source IP, destination IP. So, an IP packet comes to data link layer. At data link layer, we have Ethernet. Okay, Ethernet. Now, this takes the IP packet. It puts the source MAC address. It puts the destination MAC address. This is nothing but frame header, right? This IP packet sits completely here. IP packet. Inbuilt it has source IP, destination IP. Let's not worry about that. This is Ethernet protocol, not IP protocol. Okay. Frame headers, source MAC, destination MAC. And Ethernet also puts trailers. In trailers, it put CRC, cyclic redundancy check. This is of 32 bits. A 32-bit FCS. A 32-bit frame check sequence. Sequence for checking the frame whether if it is error-free or not. That is what CRC32 does. CRC32 is nothing but it is a 32-bit code which checks at the destination whether the data which you are sent from here at the destination it's correct or not. How it is working, I'll explain in data link layer. It is very interesting concept and very important concept. Very important. CRC, right? They'll ask you in college, they'll ask you in interview, you will also use it in your companies. If you're working in networking companies, you'll use this. You'll include a library called as CRC something. Okay? Frame headers, frame trailers. So Ethernet protocol adds frame headers, adds frame trailers, sends it out via its cables. Now Ethernet is the one which provides the cable, Ethernet cable, and it carries digital signals. Remember, Ethernet uses copper wires. Copper wires carry digital signal, electrical signals. Okay, not analog signals. Ethernet uses copper cabling, unshielded twisted pair, UTP. Ethernet, see, Gbps, the Ethernet with 1 Gbps speed, right? They use optical fiber. Optical fiber. But Ethernet with 10 Mbps, 100 Mbps, up to 100 Mbps, they use unshielded twisted pair because these are cheap. Now, Ethernet is performing physical layer function also, providing a cable and sending as signals. Ethernet is performing data link layer functions also. Okay? Okay. Now, understood about working. It will come here, Ethernet will end here. Again, NIC will take this source MAC address, it will check if it is mine or not. If it is mine, it will accept. If it is accept, it will go to data link layer. It will remove the source and destination MAC. It will remove the CRC only after checking if the frame is correct or not. After removing, it will send to IP layer, and in this way it works. Okay, understood? This was about working of Ethernet. Now, second is what versions of Ethernet use what type of transmission media. Lower bandwidth uses unshielded twisted pair. Higher bandwidth uses optical fibers. So these are the types of transmission media Ethernet uses. These are nothing but twisted copper cables. Twisted copper fibers. This is optical fiber. Optical fiber is nothing but carries light pulses. Light pulses. Clear? Now Ethernet, what is the type of encoding scheme Ethernet uses? Explained just now. Ethernet uses Manchester encoding scheme. And the types of communication in Ethernet, types of communication: unicast, multicast, broadcast. Why unicast? Ethernet can connect two devices one to one, done. Why multicast? Bro, if some person wants to send data to three devices, he can send, right? The person who has joined to the graph, he can send. And why broadcast? ARP request. I explained you. If some device some device doesn't know the MAC of other device, right? But he knows the IP. He'll send the ARP request. Who has this MAC? Who has this IP? He'll send the MAC. Broadcast. Ethernet also support broadcast. Yes, fine. Types of topology supported by Ethernet before. Ethernet was using which type of topology before? Earlier it was using bus topology. Earlier it was using bus topology. Okay. What is bus topology? While I explained bus topology, I explained you Ethernet was using this. I explained you. We have running bus here. We have small device connected to it. Now this is bus topology. Okay, one single bus, we have terminators at the end to observe the signal. Okay, as such the signal must not reflect again. Okay, device A, device B, device C. Ethernet was using this before, and because it was using this before, what type of access control it was using? But if it is using bus topology, I told you in bus topology collisions are very higher. Chances of collision are very higher. So if the chances of collision are very higher, Ethernet should have common sense that my data can be lost. Due to that, I explained you one scheme how to avoid collisions. Ethernet's access control scheme. Physical media access control. Access control means not device. Physical media access control scheme was CSMA CD. Carrier sense multiple access collision detection. Carrier sense the carrier. If the voltage is what I sent, it means no other data is there. Multiple access, multiple devices can access the medium at the same time. Collision detection. If there is no collision, okay. If there is collision, send the jamming signal to both the devices that the collision has occurred. We will resend the data. Understood? I told you topology earlier it was using bus topology. Today it's using star topology. Star topology, but with switch. It is using star topology with switch. Now, if the Ethernet is using star topology with switch, can collisions occur? So, this is legacy. Legacy means use it, but lately. Star topology along with switch, no collisions can occur because if a switch has access to source and destination MAC address, okay, switch will check the destination MAC address. It will send only to that device. And switch supports bidirectional communication, full duplex mode. First of all, total frame size of Ethernet is 64 bytes. 64 bytes. Excluding data, excluding 2 to 3 variables, 2 to 3 fields, I'll explain you what are those. Let's begin with the help of neat diagram. It's not neat, fine. Oh man. Okay. This is Ethernet frame. Ethernet frame. Okay. Bro, first one is preamble. Don't worry, I'll explain you. First one is preamble. Second is SFD, starting frame delimiter. Fine. Okay. Third one is destination MAC address. Next is source MAC address. Data. What is this data? IP payload, network packet. Data. After this, we have ether type. Ether type or length. It is also called as length, but in college they call it length, but I call it ether type. What is this relation? After ether type or length, CRC. That completes your Ethernet frame. Now, this is of 7 bytes. This is of only 1 byte. Destination MAC. How many bytes is MAC address, bro? MAC address is of 48 bits. Remember? 0A, 1B, 2C, 3D, 4E, 5F. This is of 4 bits. This is of 4 bits. 8 to the 16, 24, 32, 38, 44. 42. 48, man. 40. This total is 48. So 48 divided by 8, 6. 6 bytes. Source MAC also 6. MAC is MAC. 6 bytes, 6 bytes. Data. 46 to 1500 bytes. Ether type 2 bytes. CRC, I told you last time only, 32 bits. 32 bit means 4 bytes. Now count. 4 plus 2, 6. 6 plus 6 for it is 52. 58, 64. This all together combines 64. 64 bytes. Why do we don't include this? Because these two are actually added at the physical layer. These both. What are these? I explained, don't worry. So according to Ethernet, this is the frame. Because in framing, I told you, it starts with frame headers, adding destination MAC and source MAC. And the frame ends with trailer. What the trailer contains? Error checking. So this is nothing but frame of Ethernet. Okay? 64 bytes to 1500 plus 4, 1504, 1506, 1512, 1500, 1518. You know about destination MAC. What is destination MAC? Physical address of destination device. You know about source MAC. Physical address of source device. You mean this device, me. Data is nothing but data from packet. I mean the total packet size. Packet. Data is nothing but packet. Ether type. Very interesting. What is ether type? This is of 2 bytes. So, ether type field in Ethernet is used to actually specify what type of protocol is this device using, my device. So suppose, what protocol means not Ethernet, the network layer protocol, okay? Network layer protocol. Why? Because when you go back to because sometimes frames can go through routers, right? I told you the router does frame formatting also, data formatting. So if it needs to know what type of data formatting I need to do, he must know what protocol is being operated, right? So if it is IPv4, that is represented by some form of bits, some 0101. IPv6 is represented by some other type, some other value of the two bytes, okay? So basically, you must only know ether type is of 2 bytes, and it is the one which is used to decide what network layer protocol is my device using. Simple. Now, what is CRC? Error correction, error detection. Not error correction, error detection. Error detection. If it is error, if the CRC value is 0, it means accept the packet. The CRC value is not 0, reject the packet. I explained about CRC. It is very interesting concept. Okay. Now, I told you I'll explain this about preamble. You might be curious. 7 bytes preamble, right? So, Ethernet is very chalu. Okay. Very sharp. Okay. He don't want synchronization problems to occur at all. occur at all. No matter I am using Manchester, I am using RJ, I am using this something encoding scheme, doesn't matter. But he doesn't want even a single error in encoding the data. So to avoid synchronization issues, before even this frame starts, right? I mean, before even this part gets accepting into receiver, he makes the receiver fully prepared. So all these 7 bytes are nothing but alternative zeros and ones. Alternative zeros and ones. All 7 bytes. 7 8 are 56. 56 bits of alternating zeros and ones. So the clock should get synchronized even before my actual data starts, because actual data is sensitive here. Am I right? This must not get encoded wrong. If this and this also encoded wrong, the frame will be reset. The frame will be reset. But if the frame has gone through successfully and the actual data has come wrong, Ethernet stocks. Okay, this can happen. Okay, so all the 56 bits are actually for synchronization. Okay, now what is SFD? Start frame delimiter. So start frame delimiter is a 1 byte data which is sent to the receiver to know that from now frame is going to start. Okay, if usually most of the frames, right, they use 10 10 10 11. They use this as the start frame delimiter. If receivers get this value, if receivers accept this value signal by signal, it means it's no, okay, from now on whatever will be coming will be actual data. I mean the actual destination MAC address, source MAC address, whatever. So start frame delimiter is nothing but it is used to tell the receiver, okay, hereafter this is the starting point of the frame, hereafter whatever will be coming will be the actual part of frame. Okay, don't worry about this, we'll learn this in data and layer clearly, but now I need to tell start frame delimiter is used to tell the receiver from here the frame will be starting. This was about Ethernet in Ethernet frame structure. If they ask you to write about Ethernet protocol, छाप क्या हुआ ये? This is how beautifully it can be explained. Okay.